like for example, an AWS, we've got Elastic Beanstalk. Who knows what is an AWS? Who knows what is Elastic Beanstalk? Okay. So for this reason, basically, all I'm talking about are Docker containers. Did you notice that? So, what in case we want to scale up or make scalable something else, something which is normally not scalable, let's say, or it is scalable but this is a separate solution, like distributed databases like Cassandra, like MongoDB, for example. That's why the Mesos is very different stuff from Kubernetes. It's very different from the Docker server. It's very different from OpenStack. And let me introduce how different it is. So, first question is why we are launching our applications on top of cloud. So basically, there is number of pros and cons. Why? But I picked only two. So first of all is high availability. So besides lots of that you don't need to maintain the cloud. You're just paying the money, and somebody else is maintaining the cloud for you, basically. Let's forget about this for a while, and we've got only these two reasons why we are using cloud. So first of all is high availability. So, for example, you can launch your application and then it will be launched no matter what. So in case there will be a fire in the data center, then the application will jump to another data center, for example. Or in case you want to have like 10 instances of the applications, no problem. We can do that, for example. But what kind of high availability we have? Like geographic redundancy, so we can have our application in US, or in Europe, or in Asia. In case the data center in Asia will blow up because of some maybe nuke attack or stuff, our application will be still reachable in different geographic location. What else? We've got HW redundancy, so basically it means hardware. We've got like 10 instances in each data center, and 10 instances are spread among many servers, basically. So in case of failure of one server, no problem. 9 other servers will handle the traffic. What else? And we've got node redundancy. So for example, and this is a specific example, what happened if you're using some database as a service. So you've got account on top of database. So you haven't got your own instance of database, you've got account. So basically you are sharing the database with other users. Maybe it is within company, maybe this is with other companies like Azure does or AWS, for example. In opposite to this, we've got resource sharing. So basically, in case you want to have your database and you are not using it, some of the nodes remaining idle, and this is on several levels. What in case you have your own geographic location of AWS for you only, and you are doing nothing on this, then whole of the data center, for example, in US remains idle for some time, and then in Asia, for example, or in Europe, it's at high load, for example, over 100%, because the people are extensively using this location. That's why we've got resource sharing. So we've got redundancy between this. So basically, we've got part of our applications in one place, part of our applications in another place. But to remain the costs low, we have to share this with others, like other team members, other companies, whatever, other people, let's say. It's also on a different level. What in case of the HW redundancy? We can have a bare metal for us in data center, and we can share this bare metal with others, let's say. So this is of course cheaper. But, okay, next level of redundancy, we've got some nodes, like particular nodes on database for us, for example. but it's also profitable for us to share them with others. It's cheaper, and our demand on the CPU ticks will not be the same always, let's say. It will vary in time, basically. Yes. So, final question, optimization versus redundancy. Basically, redundancy is what in case you want to have two hardwares, two servers in different locations, or two locations, for example, or two nodes on the same database, or some other application. For you only. So this is like static provisioning here. You are asking the guy in AWS, I need two VMs, I need two nodes of the database, I need two servers in some particular location. You notice that it's, you can have it, but it is expensive. It costs money a lot. So sharing this is very good idea. And the Mesos framework basically, maybe not the Mesos framework, but the Kubernetes, for example, the Docker Swarm allows you to launch the Docker container somewhere. You don't care where it's launched. So we are approaching to the question where the redundancy and where the optimization can be done, basically. So, for example, the cloud consists of several layers, like infrastructure as a service, which is the bottom one. The middle one is platform as a service, and the last one is software as a service. So basically, in case we are not using cloud or we are using something which cannot be considered as a cloud, then we've got, for example, our PC under the desk, and we are using it. It's only for us, basically. So, for example, I usually shut down my laptop and going home at night. So this laptop can be used by somebody else in different time zones, for example. So when I share my laptop, for example, or my PC under the desk, it will become cheaper to use. So mostly AWS, that's how the Amazon starts with this Amazon Web Services, was to share the VMs, to provision the VMs dynamically. So you can just click the plus on the web page, and somewhere, you don't care where, the VM will be ready for you. You can use the VM. So this is your VM. But what in case you don't want to use this VM? This VM remains idle, and then it consumes the resources because it's running somewhere. It costs money. So what is the next level? On top of VMs, you can install some software, which can be Kubernetes, which can be Docker Swarm, which can be any other framework for the Docker containers, or maybe other solutions, but I will talk about this later. The platform as a service. So that's something that allows you to launch your application. So like on Google App, you don't care about the VMs, you don't care about the space on the hard drives, you don't care about the network. You're just putting your jar file to Google, and the Google somewhere, you don't care where, it launches your application. And the application works. It serves a service to the people and stuff like that. And last level is software as a service. So somebody made an application and gives you access to this application. So this part is easiest to explain. Who is using Facebook? So you are using application developed by somebody. This application is hosted somewhere, you don't care. And the hardware is also somewhere. This is not in the air, it's somewhere, let's say, but you don't care. You've got a link to Facebook, and you don't care about anything. This is completely done by somebody. Okay, so let's go down. In case of the path, in case you've got your application and you want to launch your application somewhere, then the path comes and you want to use path level. So basically, you've got a brilliant idea. I created, for example, some new Facebook or some new brand solution, but I want to sell it to people, for example, or I will be, earning the money on advertisements and stuff like that. But I need to to launch my application somewhere. I will not do this on my PC because my PC can be lack of power someday. It can be like far away from US because it's in Philippines, for example. So maybe better idea will be to buy a platform as a service in Google, for example, or AWS or whatever, or Azure in Microsoft. For the guys who needs the own VMs, for example, the IaaS will be the best solution. But yeah, good question. For what reason do you need VMs, for example? Yeah. In case you like to bother yourself, let's say, handling the networks, handling the firewalls and stuff like that, then the VMs is for you, basically. So this is low level, like assembler. So who is using assembler, developing the web applications? So this is the same, basically. So that's why I'm focusing today, Mesos framework is on this level, so platform as a service. So this is a framework that gives you ability to launch your application somewhere. So this is the level where you've got your application in hands and you want to launch the application somewhere. And now we are proceeding to next question. Basically, in case you've got your application, okay, let's skip this first. Shift F5. So I talked lots about Dockers because it's easy scalable, for example. So what in case we want to launch our application on top of VM? This is very easy. Basically, in case this is like third-party application, you are just putting command apt-get or yum install, and then the application is installed automatically. In most cases, you don't even need to configure this application. Basically, it just starts and it works. But the question is, what in case you want to have two applications, two instances of these applications? Whoever wanted to install two Postgres databases on one VM, how difficult is it? So, but in case of the second instance, you need to take care of the port, for example, because it's the same, let's say. The second instance wants to launch itself on the same port, so this is a problem. So you need to take your time, let's say, think what should be changed in the configuration of the second instance to make it working. And this can be easily solved by using Docker. So basically, the Docker will handle the network stuff, the space on the hardware, stuff like that. So this is like, perfect solution basically. You can launch lots of the same instances. You can launch another instances on the same VM, which are contacting with the backends in frontends or the databases, for example. It's hardware and VM independent. Okay. You can, in question answer section, you can be asking me how about power processors or stuff like that, or RISC processors. Okay, it's not necessarily hardware or software or VM independent, but mostly yes. So basically, we've got like slow bare metal, fast bare metal. We can install Docker, and we can launch the same application. We are not caring where it is. Okay, we need to care where. In case we are using pure Docker demo. But there are a number of orchestrators for Dockers, and this makes from this point, when you've got the Kubernetes or Docker Swarm installed, you need to bother where it is launched, basically. So you are launching this somewhere on some node. The Kubernetes will handle the network, the Kubernetes will handle the disk space and stuff like that. So wow, yeah, this can be, when you expose the APIs of Kubernetes, for example, or Docker Swarm, so this can be considered as a platform as a service. You're exposing API endpoints and other guys can use it to launch their application. So yes, you've got platform as a service. Okay, but I'm still talking about Docker containers. So in case we want to scale up something else, so what can it be? Okay, so I will tell you. Kafka nodes, Cassandra nodes, MongoDB nodes, for example. Okay, they can be containerized, for example. Okay, in case of Cassandra, it can be made even pretty simple. But in case of MongoDB, whoever handled the MongoDB cluster before? Yes. So this is not straightforward, let's say, in case of MongoDB, like in Cassandra, because in Cassandra you are just joining the node. But in case you want to decommission the node or, remove the node from the ring, you have to issue some commands telling the cluster that this node will no longer be present in the cluster. So these V nodes will be replicated to some other nodes, but in case of MongoDB, well, okay, so this is not the topic for today, this is about Mesos framework. So in case you want to listen more about the distributed databases, you can contact Tivo, for example, or Thomas. But what if we want to scale up or make scalable something else than Docker container? And the answer is Mesos framework. So the Mesos framework basically as I said, as was the title of my presentation, is a meta framework for other frameworks. So you can, for example, launch Kubernetes on top of Mesos. So basically, the Mesos will take care of handling the resources, or where the executor, let's call it like this right now, I will explain it to you later. The executor of Kubernetes are pods. So pods have to be launched somewhere. So the difference between like pure Kubernetes and the Kubernetes on top of Mesos is that the Mesos is aware where Kubernetes is launching the pods. So together on top of Mesos, I can launch Cassandra cluster, for example. And this Cassandra cluster launches a nodes somewhere. And Cassandra cluster can be a cluster of the applications installed directly on top of virtual machines. So they don't need to be a Docker containers. So, for example, Kubernetes will take some resources on some nodes, and Mesos is aware that these nodes are utilized, for example. So it will take care of launching the Cassandra nodes somewhere else. So it's like handling the executors, let's call it like this. So the executor of the Kubernetes will be pod. Pod consists of course, of the Docker containers, like connected with Flannel, overlay network and stuff like that. We don't talk about this right now. But in case of Cassandra, this is completely different framework, launched on top of the same Mesos framework. So in case your solution consists of like many, let's call it like this, another solutions, another frameworks, and you want to utilize the same resources, so the same cores, for example, so the Mesos framework is an answer, let's say. So consider the solution when the Kubernetes will be launched separately, and Cassandra cluster will be launched also separately, let's say. So, for example, for some time the Cassandra may not be used for some time, and the Kubernetes will be used extensively. So this is the same problem I talked before, the optimization and redundancy. So the Mesos framework gives us opportunity to share resources between different frameworks. But the Cassandra is, of course, not only an example. We've got, for example, Kafka, which is also utilizing a lot of resources when it's working. We've got Elasticsearch. Do you know LXStack, for example? Who knows what is LXStack? Okay, so Elasticsearch is a full text search database, basically. So, okay, you can consider it the same as Cassandra, for example. So, database consisting of many nodes, let's say. What else? We've got GitLab CI runners, for example. So, for those who are using Jenkins, you have to connect Jenkins slaves. So the Jenkins slaves can be easily provisioned by the Mesos. So in case the Mesos slaves are utilized, okay, I don't know whether Jenkins is, okay, so Jenkins can be also, on top of Mesos. In case the Jenkins slaves are heavily utilized, then the Mesos can scale up more. Okay. It's not like I said, this is more tricky, but it will be explained on the another side. So basically, something will scale up Jenkins slaves. So it will launch more Jenkins slaves depending on the demand, let's say. But not Mesos. This is the point. Not Mesos. Mesos is a meta framework which is aware of the which VMs are or which hardware is utilized, and it communicates with intermediate layer, which is Mesos framework. So, for example, in case of the Kubernetes, you have to install Kubernetes framework on top of Mesos. In case of the Jenkins, you have to install Jenkins framework on top of Mesos. And this thingy outside is seen as a regular Jenkins. This thingy outside is seen as a regular Kubernetes, for example. But downstairs here, there is a Mesos, and when you want to launch something on this Kubernetes framework, then it communicates with Mesos and assign the resources somewhere. So this is one point that I want you to remember after this meeting is that the Mesos provisions the resources for frameworks, no matter what framework. It is not like Docker container, because Docker container can be launched here. The Marathon is a great framework for this. Is okay. This thing can be considered as a Docker swarm. Who used Docker swarm before?
5 minutes.
Okay. So basically, the Docker swarm exposes an API route. You can launch your application on top of it. This does the same thing, basically. So another question appears: what will happen, because the Mesos, on top of Mesos, we can launch a number of different frameworks. But the most curious thing is that we can launch 2 Kubernetes framework on one Mesos cluster. You want next Kubernetes cluster? No problem. Launch it and ta-da. So just like in case of Docker containers, you want to launch 2 Postgres databases on one VM. With Docker, it's not a problem. With Mesos, launching 2 Kubernetes clusters is also not a problem. So this is like, once again, framework for frameworks, for scaling frameworks, for high availability of frameworks. Okay, so in case I've got 5 minutes only. In short words, this can be considered as an infrastructure as a computer. So on the computer, like on the VM, for example, you can do anything. And Mesos makes many of the VMs, many of the connects, like servers, like VMs into one thingy where you can launch anything. Not only Docker containers, not only Cassandra nodes. This is only, it depends only on your imagination. You can create your own Mesos framework, launching anything, let's say. And it can be launched not on one hardware or on one server, on one VM. It can be launched in data center, for example, or in many data centers. This is the point. Another thing is the utilization of the resources. So for example, we've got a number of applications here. I just copy-pasted this from Google on one Mesos cluster. So depending on the demand, the applications are run on different nodes. So for example, the idle time, so this white spaces here are idle time. It's almost zero time, basically. So we are avoiding idle time because idle time costs money. So we want to have as cheap service as possible. And so we are avoiding the time where the VMs, where the hardware are idle, let's say. And last slide, how does it work from architecture point of view? So basically, this level is our application. So our application wants to launch more Cassandra cluster, more MongoDB cluster, more Docker containers, more pods on top of Kubernetes. So it communicates with the Mesos framework, and Mesos framework consists of two separate applications. One application is constantly launched on Mesos master. So this Mesos has a okay. This is another slide. So basically, we've got some applications, which is Mesos, which is a framework scheduler. So for example, in case of Kubernetes, we've got Kubernetes scheduler and Kubernetes executor. So we are communicating with this guy, so Kubernetes scheduler, let's call it like this. And this scheduler asks Mesos cluster where are the free resources. And then the Mesos master redirects the Kubernetes scheduler to appropriate node. And it launches an application which is called Kubernetes executor, and this application is a tiny Java application, also provided together with the Kubernetes framework, and it launches the pod on some